For part A, you will be making a solution of known molarity, and you're just going to start with reactions and stoichiometry and making a solution of known molarity. All right, we're going to drag this beaker over to here and zoom in, and then we're going to weigh out some sodium bicarbonate. And that should snap into place. Then we're going to add this to the beaker. Then we're going to add water to the cylinder. All right, then when it's done, it will just go back. And we've added 50 milliliters of water to that graduated cylinder. Okay, so to look at the molarity of the first solution that we made, I weighed out 2.377 grams of sodium bicarbonate, and there was 50.0 milliliters of water. So I need to find the molarity. Molarity equals moles over liters. Right now my volume is in milliliters. I need to convert that to liters. So in 50.0 milliliters, there are 1,000 mils in 1 liter. So I can cross out my units here. And then I'll divide and get 0.0500 liters. So that's my liters. And now I need to convert my grams to moles. So it's 2.377 grams. And we're going to need to find the molar mass of NaHCO3. And you can do that by using the periodic table. So the mass of Na is 22.989. We have 1 H, which is 1.00794. 1 carbon is 12.011 grams. And we have 3 oxygens at 15.9994 grams times 3. So we're going to add all of that up, and that comes to 84.01 grams per mole of sodium bicarbonate. So if I look at how I'm going to do that, my grams are on top here, and I want those to cancel out. So I'm going to put times 1 mole, which works out because I want to have moles at the end. So that's over 84.01 grams of sodium bicarbonate. I'll cancel out my units and then divide, and we should get 0.0283 moles. And then to get my molarity, it's moles over liters. So it's 0.566 moles per liter of NaHCO3. And your molarity might be a little bit different, but the process of calculating it is the same. All right, for the next part of the lab, we're going to go to reactions in stoichiometry and choose precipitation reactions. And we're going to find a test tube from the test tube rack and put it in this here. And the first ion that we're going to use is silver. So we grab the silver ion, or just click on it, and you'll see that it fills in the tube. And we want to make more of these same tubes because we have to do 4 different tests. So just hit this divide 4 times to get 4 different samples. And then we can go ahead and do the first test, which is with sodium carbonate. And you look for the drop bottle over here and add that to there. So notice right now, even though this bottle says silver plus, those are the cations that are present. We're going to add sodium carbonate. And we notice that the solution has changed in both color and cloudiness. And if a new compound has formed, we have silver carbonate that formed. There's also some silver oxide present, and we have sodium ions. So the sodium ions are the ones that are floating around that aren't bound to anything, but you have silver carbonate here. Then we can go to the next reaction. So just put this to the side. Okay, so for the first tube, we added silver ion, which was in the form of silver nitrate, plus Na2CO3. And what we observed was the product, AgCO3, and there was a 2 there. And that was the precipitate that came into solution. So one of the ways to go about doing this is doing the ionic equation. So if you are with a friend, you have your silver and your friend is nitrate, and then 2 other friends come to the party together, you end up with silver ion plus NO3 ion, and that has a negative charge. And then there's 2 Na plus that came to the party. because of that subscript there. And then carbonate is a polyatomic ion, just like nitrate. So that is 2 minus because there was two sodiums there. So all of you guys came to the party, but you ended up changing partners. So you are silver and you're positive, so you want to attract a negative, and you're gonna party and leave the party with carbonate, and sodium is going to leave the party with nitrate. So then those two combine. So silver U is with carbonate, and now we have to balance our charges. Silver has a charge of 1, carbonate has a 2 minus charge, so we need 2 silvers to balance that. And then we also add to that, Na is going to go home with NO3 minus. All right, and if we look at our soluble salts and our solubility rules, we notice that this was a solid, which is what the tube told us, is what formed. So we had silver carbonate, and if we look at the rules for carbonates, this is an insoluble salt, so carbonates are insoluble, so that's our solid. And then so that's what the solid that was formed, because that's what the virtual lab told us. And then if you're not sure what else was there, we saw sodium ion, and the nitrate ion is also a spectator ion. And if we look at the rules for nitrates, there are no exceptions. So all nitrates are soluble salts, and also group 1A are soluble. So those are not going to be precipitates, those will be ions. And so we have silver carbonate plus NaNO3. The other thing I need to do is balance my equation. So in the front half, I had silver nitrate and Na2CO3. In the products, I have 2 silvers. So I need to add a 2 in front here. And that means I have 2 nitrates, so I have to balance this with 2 NO3. So that's how I would balance my equation. If we now look at the net ionic equation, here's the ionic equation. That has the silver ion, nitrate ion, plus 2 Na plus, and then the CO3 minus, and that gave us this product. Now we can remove all of the spectator ions. So I'm just going to rewrite this. All right, so there's the equation that is written out. We have all of the ions, 2 silver ions plus nitrate. There will be 2 of these as well because of that orange 2 up front there. There's 2 sodiums and then 1 carbonate ion. And that's going to make silver carbonate plus sodium ion and nitrate ion. All right, so all of the things are balanced, and now we're just going to remove spectator ions, and those are the ions that are going to appear on both sides. So when I remove those, I have 2 nitrates on that side, 2 nitrates here, 2 sodium, 2 sodium. So my net ionic equation is 2 silver, which is aqueous, plus carbonate, also aqueous, and that forms Ag2CO3, and that is solid. So that's how we would do our equations for silver nitrate plus sodium carbonate. I'm going to look at putting this into the stand, and the next ion I'm going to add is chloride, and I just click on this bottle, and now I've noticed that everything is gone white and it's very cloudy. And this is not an ion here, this is silver chloride, which is the precipitate. It's not soluble, but I also have sodium ions present. So I went from having sodium chloride plus the silver to having sodium ions and silver chloride. So I can move this over here, and we'll look at one more. We go through the same process for silver nitrate plus NaCl. So we're going to have Ag plus ions plus NO3 minus ions. And that's going to also go to the party with Na plus and Cl minus. All right, and now we're going to do a partner switch up. So Ag is plus, and it's going to go home with the other ion, which is AgCl, and these two will go home together. So we get AgCl, and we were told that in the lab that that was the product that formed. That was the precipitate, and then there were sodium ions left over. So we'll have a product of Na plus and also NO3 minus. Okay, so there's our total ionic equation, and then we can do the net ionic equation. And if you wanted to do a double check here with the solubility rules, AgCl formed and chlorides are in the halides, and those are generally soluble, but you can see that silver here is an exception, so that one is our precipitate. And still the sodium and the nitrates, the nitrates and the sodium, those are solubles. There's no exceptions there. So in our net equation, we're going to remove the ions that are spectators, which are nitrate and sodium, so that when we write our net, we have Ag plus Cl minus is going to give us AgCl, and that is solid. Put that in the stand, and I'm going to add sodium sulfate. And notice that no precipitate form, the solution looks exactly the same, and because there's no precipitate form, I have silver ions and sodium ions present. For silver nitrate and sodium sulfate, we saw that there was Ag plus ions and Na plus in the test tubes, so that was no reaction. Those did not form a precipitate, so you don't have to write a reaction. And you can double check the rules here. So if a sulfate were to form, we could look at the sulfates, and those are pretty soluble except for barium, lead, and strontium. And silver is slightly soluble, but the amount that we had seemed to be soluble, so we didn't have to worry about a reaction for that one.